Hey guys, welcome back. So today we're going to be looking at how to solve linear equations. So what do we mean when we say linear? What we mean is that when you get an equation, so something like 3 plus 2x equals x plus 5, the highest power of this x term is just going to be 1. You're not going to be seeing an x squared or x cubed or x to the 4. You're only going to be dealing with terms that have x to the power of 1 at an absolute maximum. Otherwise, we're just going to see numbers. We're going to see numbers and terms that have 1x, no x squareds. That's what we mean by linear. Okay, and when we're solving these equations, we're basically getting an equation like this, and this is telling us that this left-hand side is equal to the right-hand side. And we're trying to figure out what we can replace x with to make that true. What can I put x in here and here to make 3 plus 2 times this kind of number the same as that same number plus 5? Which number there is going to satisfy these requirements? Okay, so the first thing we're going to do when we're dealing with equations is we're going to make sure that we're always trying to get x by itself. So number one is isolate x. How do we do that? We take x, we get all these x terms on one side, and we get all the numbers on the other side. And that way we can actually see what x is going to be equal to. So we get x to one side by itself. We want everything else on the other side. Okay? So how do we go about doing that? Well, number two is we use something called inverse equations. Clearly in this example, we can see here that x is not already by itself. There's an x on this side and there's an x on this side. And what we can do is we want to rearrange this so that we've got all these x's together. We want one x by itself. We just want x. We don't want 2x or 3x. I just want x, and I don't want negative x. And we want all the numbers and everything on the other side so I can see what x actually equals. Okay, so to do that, what we're going to do is to get numbers off and to get these numbers off x that are attached to it, we're going to do the opposite of what is happening here. So if we look at this term here, 3, clearly 3 here is a positive 3. There is an invisible positive there. So if that's positive 3, what's the opposite of plus 3? Minus 3. So if I want to get 3 away from this side, okay, then I would minus 3 from this side and this side. Now that's the important thing here. If I take away 3 here, I also take it away there, okay? Because what you do to one side, you must do to the other side. Okay, so you must remember that rule. If you take away 3 here, we've got to take away 3 here. Why would we minus 3? Why would we do that? Because we want to get rid of the plus 3 here. And we know that plus 3 minus 3 equals 0. So that allows us to get rid of this 3. And I usually write it up here, minus 3. And then I do the minus 3 over here. And I'll just rewrite it like that. Okay, so whatever I did here, I do here. Now I know that that's gone. And now I've only got 2x on this side, which is going to equal x plus 5 minus 3 is 2. What's the next thing we do? Well, we've got all the numbers to one side. Okay, we can see that all the numbers are in this plus 2. The only other things we have is a 2x and an x. But I need all the x's on one side. So what is this x doing? This is the small x. And we know that the numbers are here. So I'm going to take this x to this side. When you decide which side you're going to take all the x's and you're going to take the numbers, because over here I could have taken the 5 to this side by minusing the 5. Why did I minus the 3 to this side and not minus 5 to that side? Because I want the x to be positive in the end. So I want all the x's to come over here because I know that 2 minus 1x is going to be 1x, which is positive. But if I had minus 2 from here, which is 1 minus 2, that's going to be negative. And I don't want negative x. We want the positive x on the other side, okay? So you can also do this x step first and then do the numbers, or you can do the numbers first and then the x's. It doesn't matter. So here we know we've got x, and I know I've got to get it to that side. What is this? Well, this is a plus x. There's an invisible plus there. So again, I'll write it in here. I'm going to have to minus x. And because I minused x here, I've also got to minus it here. Well, what's 2x minus 1x? As we just said, that is x, which is what we tried to do. We got x by itself, which equals 2. Great, so what does that mean? That means that 3 plus 2 times 2, let's write this out. 3 plus 2 times 2 should equal 2 plus 5. Well, what's 3 plus 4? 7. And what's 5 plus 2? 7. So the fact that we found x equals 2 means that this side now would equal this side, only when x equals 2. Okay? So that's the whole point of equations. Now, coming back to inverse equations, where we said you always do the opposite of what something is doing, what that means is that if you have a positive number and you want to get it to the other side, then you have to make it minus. Okay, so we turn the pluses into minuses. So if we have positive 3 here, we minus 3 from both sides. If we have a number that is times in x, I'll show that down here. Say we have 2x, which means 2 times x equals 4. Well, how do I get rid of the times x? Well, we do the opposite of times, which is divide x. And I always write divide as a fraction. We want to do these as fractions. I'll just write that here. So it would be 2 on 2. Yeah, instead of doing divided by, I'm actually going to do it like a fraction because that makes it so easy for us to see that 2 divided by 2 is 1, so that allows us to get rid of it. And because I divided 2x by 2, I've got to divide the other side by 2. So here, I would have got x equals 2, 4 divided by 2. Okay, the why we do it here is that we know we can cancel those out to get 1, which just leaves x, which is what we always try to do. Okay, so if we have times, we do divide. If we have divide, we do times. Okay, if I had, and I'll just do it over here, if I had x over 2, which means x divided by 2 equals 4, well then, what's the opposite of divide? Times. So I times by 2, because we know that 2 over 1 times x over 2, you can see here that these will cross cancel. Okay, they cancel out because they're opposite. And then because I times this side by 2, I've got to times this side by 2, which leaves x equals 8. So by using these inverse equations, these numbers are always cancelling out on the side that has x. We can see that. It's always getting rid of them, which is what we're trying to do. Another thing is that if you did have x squared, which we know isn't linear, but you'll see it later on, if you had x, I'll write it like this, squared, I'll just do it in a bracket so you can see what we're going to do here. Well, how do you undo the squared? You do the square root of x squared. So squaring and square rooting are the opposite. If I square root a square number, well, they just cancel out and they leave x. Okay, so they're the main ones you need to know for now. Also, just know that if you have brackets in the equation, you're usually going to be doing the brackets last. And I'll explain that more in just a second. So what we're going to look at now is one more example that has a lot of these kind of functions in them with pluses and timeses, and we're going to see how you know which order to do things in. Okay, so I'll just get rid of these. Okay, so let's start off with looking at an equation that goes something like this. 2x minus 14 over 3, the whole thing over 3, equals 6. Okay, well, where do I start with? Well, can I take this? I'm trying to get x by itself. Let's always start with that in our mind. Trying to get x by itself. How do I get x by itself? Well, I have to get rid of this 2, I have to get rid of the minus 14, and I have to get rid of the divided by 3. What I'm going to do first is, because I can't just plus 14 to the other side, because that 14 is actually over 3, and I can't just divide off 2 from the x like we saw before, because there's also an over 3 here, we're just going to have to get rid of the 3 first. So keep that in mind. You usually do fractions first. Okay? Fractions first. You get rid of the fractions first. Okay? So how do we get rid of this fraction? Well, we know that 2x minus 14 divided by 3 is going to have the opposite effect of when we times it by 3. So we're going to do 3 times this, and we know that these just cancel out automatically because it's like 3 over 1, and they can cross cancel. And because we times this side by 3, I've got to times everything else in the equation by 3. In this case, it's just the 6. But normally, if you times a fraction by the denominator, you've got to times every other term by that denominator. Okay, so they cancel out, so I'm left with 2x minus 14 equals 6, or equals 18, sorry, 6 times 3. And I know, and keep in mind here, that I'm rewriting all these steps. Every time I do cancel off one thing, I'm going to rewrite what we're left with, and then I'm going to keep going, okay? So what do we do next? I've got 2x minus 14 equals 18. Which one do I do first? Do I divide everything by 2 to get x by itself? And then that means I would also have to divide minus 14 by 2, and then 18 by 2. Or do we just take the 14 to the other side? And what we're going to do is we're going to take this 14 to the other side. And the reason that we do that, and this is very important, is because we're always trying to work from the outside of x, the things that are the furthest away from the x, inside to the x. We can see that 2 is attached to x. It's very close to it. Whereas minus 14 is over here, which allows us to move this to the other side a lot more easily. So we're going to do the outside of the x first, and then we're going to work our way inside to things that are attached to x. The exception is here when everything is dividing by 3. If that was just 2x divided by 3, and the fraction wasn't over the 14 as well, we would have done the 14 first before we dealt with the fraction, okay? Because that would have been further away from the x. Okay, so if we have 2x minus 14 equals 18, we're going to plus 14 to both sides. Because minus 14 plus 14 equals 0. So that allows us to rewrite this as 2x equals 32, 18 plus 14. What's the last thing we do? Well, what's 2 doing to x? It is times in it. So what's the opposite of times? Divide, and we're going to write it like a fraction, over 2. 2 over 2 we know is just 1, so it just leaves x. And because we divided this side by 2, we divide this side by 2. What's 32 divided by 2? 16. So that's how you work through an equation to get an answer. You want to get x by itself, and you want to use the opposite of what is happening to x's. Alright guys, stay tuned for the next video where we're going to look at some more fractions and some harder linear equations. See you next time.